everybody. All right, let's practice solving for forces with a two-dimensional example here. Okay, so we got two objects, right? A car and a truck. Let's say we know the weight of both. So let's start with the free body diagram of each. So like here's the truck. So there's some, this is for the truck. So there's some normal force, normal for the truck. And then let's say if the road is like this. So there's some friction force, keeping the truck from sliding back. And then the truck has weight. And then there's this tow rope. So some tow rope like this, and some tension in the tow rope. Okay, so that's the free body diagram for the truck. And for the car, let's say here's the car. So, and then if the ramp is gonna sort of like this, then there's a normal force, right? Normal to the surface for the car. There's the same tow rope, right, connected to the truck. So there's tension. The car has weight. The car, and then this is smooth. Okay, so that's it. So we got both free body diagrams. Now, how do you want to pick coordinates? There are infinite choices, right? So you can try at home if you pick coordinates like this, and then try and solve for everything. Solve for the normal forces, the friction, the tension. Solve for everything. So you can try that. I'm going to pick my coordinates like, say like this. So my strategy here is the normal force lines up with the y-axis, the friction lines up with the x-axis. So that's pretty good. Not a lot of good choices here, right? Because I can't, nothing I choose will I ever have two forces lining up. So I'm just going to go kind of the same strategy I did with the truck. Okay, so there we go. I picked my coordinates. Now again, try that like rotating coordinate strategy here, right? Like if this is horizontal, then this is 10 degrees, right? Which means this is 10 degrees. Right? This is 10 degrees. Let me write that nicer. Okay, so here to here, 10 degrees. This is vertical. Here to here, 10 degrees. Here to here, 10 degrees. But then, see, the tow rope is 18 degrees from this horizontal here. This here to here is 18, which means here to here is kind of the leftovers, right? 18 minus 10, 8 degrees. And here to here is 10 degrees. And then also for the car, this is horizontal, this is vertical. So the incline here to here is 26. Right? This is 26. But between horizontal and the tow rope is 18. Right? So here to here is 18. Which means here to here is the leftovers. 26 minus 18 is 8. Right? And then here to here is 26. Here to here is 26. Not that it matters there. And then here to here is 26. Okay. I put a lot of labels in there. So let's write Newton's second law decomposed. Okay, so x is here, right? So the x component of the friction is just positive. The x component of the weight is negative, and it's opposite the angle, right? So minus sine. The x component of the tension is negative and is adjacent to this angle equals static. Right? In the y direction, this is positive. The y component of this is 0. The y component of this is negative and is opposite this angle, sine. And then the y component of this is negative and is adjacent to this angle. Zero. Okay. Now let's go to the car. Okay, so x component of tension is positive and it's adjacent to this angle. Right, so positive t cosine. The x component of this is 0. The x component of this is negative and is opposite this angle. Okay, and then y component of t is negative and is opposite this angle. The y component of this is the whole thing, positive. The y component of this is negative and is adjacent to this angle, cosine, 0, right? Okay, and then what I like to do is literally either underline or circle the unknowns. Okay, so we know the weights. Okay, so these are the unknowns. And then we got 4 unknowns. But then by labeling it like this, it really leads me to which to solve first. Like if I look at these 4, I'm going to solve this one first, right? Because there's only one unknown. Once I know this, I substitute it here. Then I can solve for this. And then I take that value for t, put it here, solve for this. Right? That same value for t, put it here, solve for this. Okay, so that's my strategy. Alright, thanks for listening. I'll see you in the next video.